All right, so we're going to prove this summation formula by using induction. And the thing to keep in mind is that we're always looking to start with n equals 1 for the base case. If n equals 1, that means that the sum would stop at 3 times 5 to the first, or 3 times 5. So the sum of these two terms is your base case. So if we take 3 plus 3 times 5, we get 18. And if we plug it into the formula that is proposed on the right-hand side, we have this, which is 3 times 24 over 4, which is good, 18. So there's our base case that is proven. So now, the inductive hypothesis, we're going to assume that 3 plus 3 times 5 plus many in the middle plus 3 times 5 to the k is equal to this thing over here. So then what we want to show is that when we add an additional term that follows the same format, these always take a little bit of time to write. So I'm going to write 3 times 5 to the k plus. Now the next one is just going to change k to k plus 1, so that's what we have there. And it's pretty simple to see with this one. All we want to do is show that it's equal to 3 times 5 to the k plus 2 minus 1 over 4. So that's where we're going. So this piece we know is replaced by inductive hypothesis. And then plus 3 times 5 to the k plus 1. So what seems to be the best strategy here? Well, I'm guessing we'll make a common denominator since our final expression should have a common denominator. So this is 3 times 5 to the k plus 1 minus 3 plus 4 times 3 times 5 to the k plus 1 all over 4. Now this isn't looking too good right now, right? Because it just doesn't look like it's falling together. Don't worry, it will. So if we add this term and this term together, so this is 12 times 5 to the k plus 1. So that means this is, well, we could say 15 times times 5 to the k plus 1, but I'm going to write this as 3 times 5 times 5 to the k plus 1 minus 3 all over 4. And would you look at that? 5 times 5 to the k plus 1 is 5 to the k plus 2. So there it is. And just to make it look exactly the way we want it, I'm going to factor out the 3 from the numerator. And there we have it. This formula is proven. We got to the next step, assuming the last step was valid. And again, the base case leads that chain, right? N equals 1 leads to 2, leads to 3, and so on and so forth. So if you have a sum of that format, here's your formula for the sum of the first k terms.